Hello ladies and gentlemen, we are starting our second day of solving quadratic equations. This topic is so critically important we will spend 2 days on it. Problem 1 here, we're going to, well, you notice that not everything is set equal to 0. The first step when solving any quadratic is set the equation equal to 0. That should be written in your notes. Set the equation equal to 0. Keep x squared positive. You saw the example we did in class yesterday, that homework assignment, that having negative x squared plus x plus 30 made the problem very confusing. Multiplying everything by negative 1 is what we did to fix it, but if we just keep x squared positive, we won't have to worry about that. So I'm going to subtract 2x from both sides, getting x squared minus 2x equals negative 1. Then I'll add 1 to both sides. X squared minus 2x plus 1 equals 0. I'll make my puzzle. AC is 1, B is negative 2. Factors of 1 that add to be negative 2 are negative 1 and negative 1. So this becomes x squared minus 1x minus 1x plus 1 is equal to 0. Scroll down here. Factor the GCF out of the first two terms. That's x times x minus 1. I am going to have to change the sign of this plus 1 at the end. So I'll factor negative 1 out of the last two terms. And take the GCF. And what's left over becomes the other parenthesis. I'm going to make my t-chart now. X minus 1 is equal to 0. Add 1 to both sides. X equals 1. Take the other one. X equals 1 here as well. And this is a perfect square trinomial, so you're only going to have one answer. Now I told you quadratics are supposed to have two answers. And you do see that we do have two answers, but it's the same thing repeated. You don't have to list x equals 1 twice. For problem 2 here, this is different to two squares factoring, so the easiest way to do it is to add 64 to both sides. Get m squared equals 64. So this is the one problem where it's actually kind of a pain in the neck to set it equal to 0. Now you saw a problem like this. This was your second problem you did on your homework yesterday. Take the square root of both sides, and we have to not only give the principal root but also the negative root, so negative 8 as well. Quadratics are supposed to have two solutions unless they're a perfect square trinomial like in problem 1. And you'll still get two answers anyway, it's just the same answer repeated. Alright, problem 3. So we just saw a trinomial, that was problem 1. Difference of two squares was problem 2. For problem 3, 4s is not a perfect square, so don't take the square root here. Subtract 4s from both sides. You get s squared minus 4s is equal to 0. Factor that s out, and then we'll make our t-chart. When you have an s in front of parentheses like that, that means 0 is one of your roots, so you can write it down, box it up, and then s minus 4 is treated like the last couple. Or I should say problem 1. We didn't do this with problem 2. We kind of used a little shortcut. So s equals 0, s equals 4. In problem 4, we have to get rid of these parentheses. So we're going to distribute, I'll switch colors here. We're going to distribute x squared minus 2x is equal to 35. And then we're going to set this equal to 0. X squared minus 2x minus 35 is 0. We'll do our puzzle. Factors of negative 35 that add up to negative 2. Well, one of the tricks is start with the factors that are closer together. And the closest factors together would be 7 and 5. 7 times 5 is 35, and if I make 7 negative, negative 7 plus 5 is going to be negative 2. So we get x squared minus 7x plus 5x minus 35 is equal to 0. I'm going to factor x out of these. I'll factor 5 out of those two terms. And then I'm going to factor whatever's common to these two. And that's x minus 7. So x minus 7, and then what's left over is the x plus 5. At this point in time, you can forego the t-chart, and maybe you're seeing a pattern here. But for those of you who need it, we'll switch to green. St. Patrick's Day is coming up, so let's use a little green this week. X minus 7 equals 0. We'll add 7 to both sides. X equals 7 is an answer. X plus 5 equals 0. Subtract 5 from both sides. X equals negative 5 is our other solution. So X is negative 5 or positive 7. And if the directions were to tell you put your answer in set notation, we're just going to put them in curly brackets. On the Regents exam and multiple choice, I love to give you these answers in set notation. So you got to be comfortable looking at it. Alright, read the directions. It'll tell you if you need to do that or not. And if green is too light, let me know. I've had some people tell me it's fine. But if it bothers you, let me know and I won't use it anymore. We have a proportion, and what you were told to do when solving proportions is put parentheses around the binomial. This becomes x times x plus 1. Because there's parentheses there, you can see that you have to distribute. So we get x squared plus x equals 6. I'm going to subtract 6 from both sides. X squared plus x minus 6 equals 0. We do our puzzle. Factors of negative 6 that add up to be 1. Well, 3 and 2 are the ones that are closest together. And if that 2 is negative, they'll multiply to be negative 6 and they'll add up to be positive 1. So x squared plus 3x minus 2x minus 6 is equal to 0. Factor the x out of these first two terms. I'll factor the negative 2 out of those two terms. And then when I take the x plus 3 out of both terms, what's going to be left is the x minus 2. I can go with a t-chart here. X plus 3 is equal to 0. X equals negative 3. X minus 2 is equal to 0. X equals 2. And there you go. Number 5. Here's our last one today. This looks pretty complicated. Easiest way to get it done is to dig right in. You notice that x minus 1 on top, it doesn't have parentheses. Well, I can rectify that pretty quickly. I have x minus 3 times x minus 1 on the one side. On the other side, negative 4x times 2. Well, it's a good idea to work off on the side because I have to do double distributive property to multiply x minus 3 times x minus 1. So we got negative 3 times x minus 1. X times x is x squared. X times negative 1 is negative x. Negative 3 times x is negative 3x. And negative 3 times negative 1 is plus 3. So I have x squared minus 4x plus 3. And that's what goes over here. X squared minus 4x plus 3. On the right side, negative 4x times 2 is negative 8x. So, back to blue. I'm going to add 8x to both sides. We have x squared plus 4x plus 3 is equal to 0. And that is what I'm going to have to factor. So I make my puzzle. Factors of 3 that add to be 4 are 1 and 3. Of course, 3 is a prime number, so you don't have a lot of choice here. So x squared plus x plus 3x plus 3 is equal to 0. Let's scroll down. Whatever's common to these two, that's an x. Whatever's common to these two, that's a 3. Alright. And then I'm going to factor x plus 1 out of both terms. And we make our t-chart. I notice I'm skipping a little step here. In the left side of the t, I subtracted 1 from both sides. On the right side, I subtracted 3 from both sides. So that's typically a step that students will skip once they become proficient. Have a great evening. We're going to do some evens here, as you can see, tomorrow in class. There is no quiz tomorrow. We're going to save that for later in the week. And please remember to bring your money in for your review book, $8 by next Friday. Have a great day.